I'm going to do a triangle. I don't want to draw a camera every time. But the commutative property means that you should be able to switch the order of the operation and it doesn't change the result. So W triangle X should be the same thing as X triangle W. Okay, so to figure out what W triangle X is, we look at W across the row. So this W and this set of options and the X in the column. Okay, so W and X meet at X, so that's the value. X triangle W means you look at X on the row and W on the column, see what they make. It makes Z. X on the row, W on the column makes Z. So we know it does not obey the commutative property. Those two things would have to be equal if it was to obey the commutative property. And you can stop there. Once you've found one example that doesn't obey the commutative property, you don't need to go looking for any other one. Oh. Okay, so no commutative property. Let's try associative. Associative property means that we should, here, do a triangle, means that something should look like this. Look, if you read them left to right, the letters go in the same order. I've changed the parentheses. If it obeys the associative property, then this should be true for any arrangement of letters that we have in our table. Okay, so W triangle X triangle Y. You got to do parentheses first. So X triangle Y, X in the row, Y in the column. Those meet up with the letter X. So we will replace that parentheses with X. And over here, W triangle X, W in the row, X on the column, that meets up with the value of X. And then we got to simplify some more. We got to do W triangle X. We go to W on the row, X on the column, you get X. If you do X on the row, on the rows, and then Y on the columns, that gives us X. So this is an example of the associative property. It's looking good for the associative property, but it's not enough to do just one example. It actually has to work for every possible example you can think of. So that's why these questions are tough, because you could try a few examples, you find that it's obeying the associative property, but then there's actually one example hidden in here somewhere that does not obey it. So let's go looking a little bit more before we make our guess. Okay, let's do W triangle, let's throw in a Z. W triangle Y triangle Z, let's see if that's equal to W triangle Y in parentheses triangle Z. Right, so the only thing I've changed is the parentheses. It still is from left to right the same letters. So we got to do the parentheses first. We got to do Y triangle Z. So Y in the row, Z in the column, that gives us X. W in the row, Y in the column. W in the row, Y in the column gives us Y. And then W triangle X, W in the row, X in the column gives us X. Y in the row, Z in the column gives us X. It's still looking good for the associative property. Those two things do equal each other. So we'll try another one. Let's try Z triangle W triangle Y. And we'll put a parentheses around these. That's equal to Z parentheses Z triangle W triangle Y. Okay, W triangle Y, W on the row, Y in the column gives us Y. Z on the row, W on the column, Z, W meets up with the letter X. Okay, Z triangle Y, so Z in the row, Y in the column, that gives us Z. X in the row, Y in the column, gives us X in the row, Y in the column gives us X. So unless I mess something up, I just found an example where it does not obey the associative property, so this is neither.